Good morning all of you. Today is the first class of this session, Physics Chapter 1 Force. Before we start the chapter, we have to know what is force. A force is a push or pull upon an object resulting from the object's interactions with another object, and the SI unit of force is Newton. And here we are getting number A, moments of force and equilibrium. So what is moment of force? And here the linear and transitional motions. So when a force acts on a body which is free to move, the body starts moving in a straight path in the direction of the force. This is called the linear or transitional motion. For example, a bullet targeted from the pistol. Now the second point, rotational motion. So what is rotational motion? Rotational motion can be defined as a motion of an object around a circular path in a fixed orbit. It can also be defined as the motion of the body in which all of its particles moves in the circular motion with a common angular velocity about a fixed point. For example, the rotation of Earth about its axis. Now we will move to moments of force. Moments of force is a measure of its tendency to cause a body to rotate about a specific point of axis. SI unit equals to Newton meter, that is Nm. And here the formula for moment of force is equals to moment of force about point O equals to force into perpendicular distance between the line of action of force and the axis of rotation. For producing the maximum turning effect, the given force should be applied at the farthest point of the axis of rotation. As we know that the SI unit of moment is Newton meter and the CGS unit of moment is equals to dyne into centimeter equals to dyne centimeter. The gravitational unit of torque or moment of force are SI gravitational unit is to kilogram force into meter equals to kgf into meter. CGS gravitational unit gram force into meter equals to gf into meter. The various units of torque are related to each other as follows: 1 Newton meter equals to 10 to the power 7 dyne into centimeter, 1 kgf meter equals to 9.8 Newton meter, and 1 gf centimeter equals to 981 dyne centimeter. Now what is clockwise and anti-clockwise moments? If the turning effect of force tends to rotate the body about a point or an axis in an anti-clockwise direction, the moment of force is called the anti-clockwise moments. As per convention, anti-clockwise moment is considered positive. And now, what is clockwise moments? On the other hand, if the turning effect of force tends to rotate the body about a point or an axis in a clockwise direction, the moment of force is called the clockwise moment. As per convention, the clockwise moment is considered negative. Now, some applications of moment of force. A long spanner is used to loosen a tight nut. Number 2, it is easier to open a door by applying force at the free end. Number 3, the hand floor grinder is provided with the handle near its rim. Next one, a small child can balance a heavy person on a seesaw by sitting at the greater distance from the axis of rotation. And next number, steering wheel and bicycle pedals. These are the examples of moments. Now couple. A couple is a pair of forces equal in magnitude, oppositely directed and displaced by perpendicular distance or moment. The simplest kind of couple consists of two equal and opposite forces whose lines of action do not coincide. This is called a simple couple. The SI unit of couple is Newton meter. The gravitational unit of couple is kilogram force into meter, that is kgf dot into meter. The CGS unit of couple is dyne centimeter. The gravitational CGS unit of the couple is GF into centimeter. Some examples of couples in daily life are turning the key in a lock, turning the tap, turning a steering wheel, opening the cap of an ink pot, turning the screwdriver. These are the examples of couples actions in daily life. Now we will move to equilibrium of bodies. So what is equilibrium? The condition of a system when its state of motion nor its internal when neither its states of motion nor its internal energy state tends to change with time. There are two kinds of equilibrium, static equilibrium and dynamic equilibrium. And some of the conditions for a body to be in equilibrium are: number 1, the resultant of all the forces acting on the body should be equal to 0. Number 2, the algebraic sum of moments of all the forces acting on the body about the point of rotation should be 0. Now we will move to the principle of moments. According to the principle of moments, if the algebraic sum principle of moments, according to the principle of moments, if the algebraic sum of moments of all the forces acting on the body about the axis of rotation is 0, the body is equilibrium. That is, sum of the anti-clockwise moments is equals to sum of the clockwise moments. And later we will start exercise number B, and for the time being it's time to say goodbye. Thank you. Have a nice day.